Class 10 standard ICSE student, listen carefully. Alkali metal are the most active metal in the periodic table. But do you know they are more similar with the halogens? Yes. Before starting that concept, welcome to our YouTube channel. We will going to discuss the comparison of alkali metals and halogen. This is based on the chapter 1 periodic table of class 10 ICSE, and this is the part 11 video of this chapter periodic table. We discuss all the concept based on concise, that is Selena. Today I already told I will going to discuss the comparison between alkali metals and halogen. Now look at the board. We will discuss so many topics that given in concise, but two most important and basic concepts are physical state and valence electron. Okay, these two topics you have to memorize for short question. If this question will come in exam, compare the properties of alkali metal and halogen. This is my suggestion, avoid these 2 points because these are mainly for MCQ or short question. I will give 3 to 4 or more than that very important points for alkali metals as well as halogen. If you write that points when this question will come comparison between these two, then you will definitely get full marks, but memorize these 2 points for short question. Now physical state, keeping in your mind alkali metals, shining, white, soft metal, these 3 points you have to remember. Shining metal, white as well as soft, okay, can be cut by knife, so they are very soft, already written. But exception is lithium. Lithium is hardest one. Okay, so generally alkali metals are soft, but lithium are hardest one. Okay, now come to the halogen. These are white, but keeping in your mind all the halogen are colored, okay, and diatomic. Diatomic means see F2, not F, Cl2, Br2, I2, so 2 atoms are there, F, that is F2. Okay, so colored, what is the color? Keeping in your mind, fluorine is poisonous, chlorine is poisonous, bromine is poisonous, but not iodine. Okay, so fluorine, chlorine, bromine, first 3 are poisonous, last one is non-poisonous. Color, it is yellow gas, it is green but gas, it is reddish brown or red brown, but keeping in your mind these two are gas but it is liquid, and iodine is solid. What is the color? Dark gray. Okay, so all of you understand this point, memorize this factual data. Now valence electron, all of you know, if you already prepared the part 1 to part 10, you can easily tell this answer. In case of alkali metal, the last shell contain 1 electron, and alkali metal present in group 1. Alkali metal present in group 1, and last shell also contain 1 electron. See, valence electron means the electron present in last shell. So since last shell 1 electron, so what is the valency of alkali metal? 1. Okay, now since its inner shell there is 8 electron, look at the board. In the inner shell there are how many electrons? 8. So from this concept you can easily tell if this last electron, if alkali metal lose the last electron, then they have octet. So all the alkali metals have a tendency to lose the last electron. Why? To gain the octet, that is more stable electronic configuration. So that's why any alkali metal like sodium, after lose 1 electron it form Na plus. Keeping in your mind, after losing an electron it become positive charge. So what is written here? Positive charged ion, that is Na plus. Okay, so what is the valence electron? 1, positive charge. Okay, now same, if you cover all the previous topic, you can easily tell halogen present in group, which group? 17. Halogen present in group 17. So 17 means I already told in previous part 10 plus 7. Okay, so 10 plus 7 means outermost shell contain how many electrons? 7. So outermost electron here, outermost shell contain how many electron? 1. So valency 1. Here outermost shell contain how many electrons? 7. So valency C 7. Okay, now look at the board. Here outermost shell contain comparison, no comparison. So compare with the alkali metal first. Here outermost shell contain how many electron? 1. So after losing it has octet. So it has a tendency to lose. Now tell me here outermost shell contain how many electrons? 7. So if it accept 1 electron then it have octet. Okay, all the halogens have octet. So halogens have a tendency to accept electron to fulfill its octet. So all of you know, after losing an electron it become positive charge, and after acceptance of electron it become negative charge. So outermost shell contain how many electrons? 7. So valency 7. Since it is 7, so it has a tendency to accept an electron, so become negative charge, anion. Done. Now look at these 3 points. These are very important. Okay, these are good conductor, these are non-conductor. Why? Keeping in your mind, conductor means who conduct the electricity or electron. Keeping in your mind, conductor means the element has loose electron. Why? Because electron conduct electricity. Now since electron conduct electricity, here it lose 1 electron. So good conductor, because these loose electron conduct electricity, but here it accept electron. So there is no electron are available. Here electron available. Why? Because it lose but it gain. So since here no loose electron are available, so it is non-conductor. Okay, now it is highly reactive. It is also highly reactive. If you cover the previous part, I am definitely sure you can tell this answer. Look at the board. Reactivity or reactive means both. Reactive means both. If any atom lose the electron, it is reactive, highly reactive. If any atom accept electron, it is also highly reactive. So see here, it lose electron, highly reactive. Here 7, so accept electron, highly reactive. So reactivity means both acceptance as well as lose of electron. Okay, now here it is electropositive. Why? See, because it lose electron, lose means positive. So it is electropositive metal. And tell me, it lose or accept electron? Accept. Now it is electronegative metal. Can you tell me one mistake is here? Which one? Keeping in your mind, lose means metal, and if accept then it become non-metal. It is not metal. It is what? Electronegative non-metal. Do you understand why? Acceptance means non-metal, lose means metal. So see how many points you cover here. Physical state, exception, here all the color, which one is gas, liquid and solid, here valence electron, charge, conductance, reactivity, electropositive, electronegative. So many points are there. So many MCQ question or 1 marks question will come from this topic. Now next point, based on Selena, I will discuss the next point. Okay, now look at the board. I already told previous 2 points that I was already discussed these 2 points for short question. But if this question will come, compare between these two, then it is my suggestion, write down these points, not the previous 2 points. Okay, what is the points? First, ionization energy. Now look at the board. You can make your own note if you complete already these previous 1 to 10 parts. What is the ionization energy? Ionization energy means lose of an electron. Okay, now all of you know alkali metals means which group? Group 1. Halogen means group 17. So alkali metal present in left hand side of the periodic table, this side, group 1, and halogen means right hand side, extreme corner. Okay, after halogen only one groups are there, group 18, then and this is the last column of the periodic table. So it is extreme right hand side and it is extreme left. Why? First number C and it is second last number. So all of you know, as we move from left to right, the radius decreases. So now tell me, ionization energy means loss of an electron. So if here electron present and here also electron present, tell me where the more attraction will play. Obviously here, because radius here less, so nucleus can easily attract, nucleus means positive charge, so positive charge easily attract the negative charge, like magnet and iron. Distance less, so attraction more, but here see distance increases, so attraction less, so it can easily lose an electron. Here attraction more, so cannot lose. So ionization energy of alkali metal is less than halogen, because lose of an electron, here less amount of energy is required to lose it, it automatically lose, but here more energy is required, and energy means ionization energy. See, IE, ionization energy. So you can make this point as a differentiation between these two. Since, what is the point you can write, since the radius of halogens are less as compared to alkali metals, so in halogen there is more nuclear force or attraction by the nucleus towards the outermost electron, so more energy is required to remove an electron. So ionization energy of halogens are more than that of alkali metals. Do you understand? Okay, now fourth point, this point for comparison. Fourth point is electron affinity, already discussed in previous part. What is electron affinity? Opposite of ionization energy, gain of electron. Now based on the same diagram, you tell, here radius is more and here radius is less. So if some free electrons are available, suppose here these are free electron, so which atom has more tendency to accept, because ion electron affinity means gain, so which has more tendency to gain? Obviously this, because here radius less, so more attraction, so it can easily accept electrons but it cannot. Okay, so ionization energy of halogens is also more than that of alkali metals. Okay, so what is the point? Since the radius of halogens are less, so it has more attraction to accept the electron, so ionization energy of halogens are more than that of alkali metal. Understand? Okay, now next point, electronegativity. Okay, what is electronegativity? Already discussed. This is two electron present in a bond. Electronegativity means attraction this bonded electron towards itself. See the diagram here, electron present in between the at the middle of the bond, but here A attracts the electron towards itself. This attraction is known as electronegativity. Now can you tell me which has more attraction, any one of the alkali metal or any one of the halogen? Which has more attraction? Obviously halogen, because already told halogen has less radius, whereas alkali metal has comparatively more radius, so here attraction more, so it can attract electron with the more force, so electronegativity of the halogens are more than that of alkali metal. So what is your point? Same point, since the radius of halogens are less, so it has more attraction or more power to pull the bonded pair of electron towards itself. So halogens have more electronegativity than alkali metal. Okay, done. Okay, now another point, just you memorized, for alkali metal MP means melting point or BP means boiling point. Keeping in your mind, for alkali metal, as we move downwards, melting point or boiling point decreases, and as we move downwards, here melting point or boiling point increases. Okay, here melting and boiling point increases. Okay, memorize this point. Okay, now next point. Now our next point, that is point number 7. If you open concise, then you can see that I covered all the topics, that is all the points given in this series, comparison of alkali metal and halogen. 9-10 points are given. I covered all the points. Okay, look at the board, 7 points. Okay, 7 point is reactivity. Okay, reactivity. Tell me, I already told reactivity means both. If any atom has a tendency to lose an electron, this is highly reactive. If any atom accept the electron, this is also highly reactive. So reactivity means both acceptance as well as lose of an electron. All of you know the alkali metal radius is comparatively more than that of halogen, because halogen right hand side, and all of you know as we move left to right, radius decreases. So now, which has more tendency to lose an electron? Obviously this one, because more radius, less attraction. Okay, so it lose an electron, so it is metal or non-metal? Metal. Okay, now tell me, it has a tendency accept an electron. Why? Because smaller radius, so more attraction, that I already told, so it is non-metal. Okay, so since it lose an electron, so it is reactive. Since it is gain electron, it is also reactive. Reactivity means both. So from this point you can easily compare this point. Reactivity, it is reactive metal, but it is reactive non-metal. So you can write, in case of alkali metal, it has a tendency to lose an electron, so it is reactive metal. In case of halogen, it has a tendency to accept an electron due to its smaller radius, so it is reactive non-metal. Okay, done. Now most important point for short question as well as for this comparison, reactivity with or reaction with water and dilute acid. Okay, look at the board. Alkali metal highly reactive and vigorously reactive with water and acid, dilute acid. But halogen, these all halogen generally do not have tendency to react with water and dilute acid. So it is a difference. So keeping in your mind, alkali metals react vigorously with water and dilute acid, but halogens do not react with generally with water and dilute acid. Okay, now tell me, alkali metals are reactive or non-reactive? Obviously reactive, because it has a tendency to lose an electron. Now tell me, as we move downwards, radius increases or decreases? All of you know radius increases. So can you tell me which has more tendency to lose an electron? This first or second? If the distance between magnet and iron increases, so attraction become less here. Since the distance increases, it is positively charged and it is negatively charged. Distance increases, so attraction become less, so it easily lose an electron. So since it easily lose an electron, so it has more reactivity than this atom. So from this point you can conclude, as you move downwards, since radius increases, reactivity also increases. Again, as you move downwards, reactivity increases. Why? As we move downwards, radius increases, attraction by the nucleus towards the electron decreases, so atom easily lose an electron, so reactivity decreases. So again this point, alkali metals react vigorously with water and acid, and as we move downwards, this reactivity again increases. But in case of halogen, they do not generally react with water and acid. Done? Okay. Now, next point. Point number 9. Okay. Okay. Point number 9 is about atomic radius. I will tell it at last. Point number 9 is reducing and oxidizing agent. Very, very important concept. Most of the students face difficulties to understand these two concepts. So give focus. What is reducing agent? Any element which lose electron is reducing agent. So keeping in your mind these two, reducing means lose an electron. So obviously oxidizing agent means gain of electron, gain of an electron. So memorize this word. Reducing means lose, oxidizing means gain. Okay, now can you tell me alkali metal has more tendency to lose, or halogen has any one of the halogen has more tendency to lose? Since the radius of alkali metal is more, so it can easily lose. So alkali metals are very good reducing agent. Very, very important question for your board examination. Alkali metal, since it has comparatively large radius, then it can easily lose an electron and they behave as good reducing agent. Halogens has comparatively lesser radius, so it can easily accept an electron. Acceptance means oxidizing agent. That is why halogens, all the halogens behave as good oxidizing agent. Okay. Now, another point with the same number, same point number 9. Alkali metals generally form electrovalence compound. Alkali metals are generally form electrovalence compound, but keeping in your mind, halogens form both electrovalence as well as covalent compound. So halogens electrovalent plus covalent compound. Okay. Now here memorize two example, NaCl and KBr. Okay, here you can memorize NaCl and KBr. Okay, here for electrovalent you can memorize here KBr, here you can memorize KCl. Okay, and for covalent you can memorize HBr and HCl. Both two examples, these two, HCl and HBr. Okay, so done. This is very, very important point. Alkali metals means reducing agent, halogens means oxidizing agent. Alkali metal can form only electrovalent compound. Example, these two memorized it, and halogen form both electrovalent as well as covalent compound. Now the last point, that is, see the point number, already we covered all the 10 points. Okay, so last point. Okay, now see first. First 2 points that I discuss in this part 11, first 2 points for factual question 1 marks. Point number 3 to point number 9 for long question comparison. Point number 10 is not so much important. Okay, what is point number 10? Tell me the radius of alkali metal. Already all of you know the radius of alkali metal is more or halogen is more. So obviously radius. So point number 10 is radius. So alkali metals, the radius of alkali metal is more than that of the halogen, and radius increases as we move downwards. Here also radius increases as we move downwards. So what is the last point? The radius of alkali metals are more as compared to halogen, and in both cases as we move downwards the radius increases. Okay, so done. We completed each and every line, even in between the line, all the point, all the topics that given in concise Selena. This is the part 11 video. If you covered all the parts from 1 to 10, you can check the playlist in this channel. In playlist all the parts are there. Follow and prepare this chapter periodic table part wise. Open the playlist, first complete part 1, part 2 and so on. If you cover all the 11 parts, then you can definitely attempt all the question that will come in your board exam ICSE class 10 from this chapter periodic table. Now in next we will start question bank series. In question bank series we will cover previous year question chapter wise, most important chapter wise question from concise in text question as well as question given in exercise. Okay, so this is the complete part of this chapter. In next we will start the next chapter. So prepare and solve the question answer. For more question answer, you can join our WhatsApp channel, link given in description box. Thank you.